In section 2.4, we are going to learn something called the chain rule. The chain rule. This particular rule, I have been sort of avoiding. I've been giving you the easier problems up until now. Everything you've done up until now have been the easier problems. Okay? These ones, this is the final thing that we're going to do in section 2. There's 5 sections that we're covering in chapter 2. This is the concept that you are going to need to be able to do the more complicated derivatives. Okay? And what it basically wants you to look at, if you're trying to find the derivative, d over dx means if I'm trying to find the derivative of a function that has u as its variable, that would be the derivative of the outside piece and times the derivative of the inside piece. That's what I want you to think of it as. It's a derivative of the outside times the derivative of the inside, and sometimes even the derivative of the inside of the inside. Okay, so the chain rule works from outside in, and I want to give you an example. Okay, this for example. Okay, I'm going to do it the long way. I do not recommend you write this one down. Just watch and pay attention because just save your pen time.
Don't write it.
Don't write this one down. Okay. X plus 1 quantity squared. If you were to FOIL that out, if I were to FOIL out x plus 1 quantity squared, you all know that it would be x squared plus 2x plus 1, right? And the derivative of that, so let's call this f of x, and f prime of x would equal 2x plus 2. Agreed? Okay. Now, I want to show you what this looks like using the the chain rule. Okay? The chain rule says that you're going to work from outside in, basically. That you want to treat this piece here, this x plus 1, you want to treat it like it is a u squared. And if I were to ask you to find the derivative of u squared, if I was doing it this other way, I would do the outside and get 2u to the first power. Agreed? Okay. What was u? U was x plus 1. So this is kind of like it's 2 times x plus 1 to the first power. Well, this is not the same, or is it the same as that?
Same.
It is the same. Okay, and I messed up because I wanted one that wasn't the same, but that's all right. Good thing you didn't write it down, right? Technically, it wouldn't be the same until we took the derivative of u with respect to x, okay? And what is the derivative of u? What is the derivative of the inside piece right here? What's the derivative of the inside piece right here? 1. So it's not the same until we multiply it by this additional 1. Here, 1 was the number that makes this still equal to that. And I'm saying that because what if I were to change this to 2x plus 1 squared? Let's do that one. 2x plus 1 squared. If I had 2x squared plus 1, you guys know that that would expand out to be 4x squared plus 4x plus 1. Agreed? And the derivative of it would be 8x plus 4x. Yeah, let's. No. 8x.
4.
Thank you very much. And let's call this g of x, and we'll call this g prime of x. Okay? Now let's try to use the chain rule as a part of it. So I'm going to try to use the chain rule right here. The chain rule would say, take the derivative of the outside piece. Pretend that this is a u. Pretend 2x plus 1 is a u. And if you did the derivative of the outside piece, you would have 2. Leave the inside piece alone. Just do the derivative of the outside piece. And then you multiply it by the derivative of the inside piece. What's the derivative of the inside piece?
2.
2. So if I just did the derivative of the outside piece, I would have 4x plus 2. And see how that's not the same? It's not the same until you multiply it using the chain rule. Does it make sense so far? Would you be able to do it?
Where do you have to do from?
Inside.
This is kind of like we're doing the derivative of the outside piece, and then this is the derivative of the inside piece. You're thinking of it, if I look at that chain rule over here, this is considered you found the derivative of the outside piece, and then you have to find the derivative of the inside piece. The chain rule specifically is for when you have something that can be, that you can take the derivative of the outside and the inside, and it gives you an order to it. So I want you to try one. Here's example number 2. Recenter. You try. This is the one I want you to write down. Find dy dx for y equals x squared plus 1 quantity to the third power. The quantity of x squared plus 1 to the third power is how I should say that.